Okay, guys, so after class, I was looking at this and I realized that I'd made a mistake whenever I was setting up this lab originally, which I have now rectified so that next semester we won't have the same issue. But, okay, so what we had originally, and I'm hoping this is going to show like I want it to, I've gone ahead and I've set up the PCs and the switch, and I labeled the PCs with their address and the server with its address. Okay, now if you're going to have an access control list, the access control list is only going to be effective on things that are going in and out of your router. So like we were going to set this G00 line so that it had an inbound access control list that would filter out traffic from the .12 PC, but allow everything else through. So if we look at this guy right here, we're going to open this dude, desktop, command prompt. Okay, ping 192.168.1.11. Okay, give it a second. I haven't really programmed this. I think I put the IP addresses on these guys. I may not have. Okay, hold on just a second. I'll be right back. Okay, so open up IP config here, and sure enough, there's no address. Okay, so I labeled the drawing, but I forgot to address. .1.11. Okay, and then we're going to use that. And then we haven't programmed our router yet, but we're going to program it so that facing this network is 1.1. Okay, so we've got that taken care of. Now let's program PC2 right quick. 192.168.1.12. Same subnet mask. Subnet masking made easy. Okay, so these guys are both facing 1.1. Okay, now let's see this router. Okay, I don't have any access lists yet. Let's see. Oh, wait a minute. I may have already programmed the IP interfaces. Yes. Okay, so I've already got the IP addresses on the router interfaces, and you're going to see that gigabit 0 has got a 1.1 and gigabit 1 has got a 2.1. This is because what we have to do if we want this lab to work correctly, we have to put the server on a different network. So this guy's going to be on the 192.168.2.0 network with an address of 100. Okay, so, man, did I bother to put an address on this guy? Nope. 192.168.2.100. I started playing with this and then I went to lunch. And then when I got back, I forgot what I did. 68.2.1. Because remember, the IP address of this router interface 1 is, this is G01, and it has an interface address of 192.168.2.1. So the server is on a different network than everybody else. Okay, and then we're going to see how the ACL works. Okay, ping 192.168.2.100. And we should be able to do this because the router is directly connected to both networks, so it should automatically route for us, and it does. Router programming becomes a challenge when you're talking about networks that are separated by multiple layers of routers, and then it can get tricky very quickly. Okay, so let's go to this PC and try the same stunt. Ping 192.168.2.100. Okay, cool. So both PCs can ping that server. All right, now then, we're going to establish an ACL that will block traffic from 1.12 but allow traffic from 1.11. Okay, so now, same thing we did in lab. The commands are going to be the exact same thing that we did before. Okay, we're going to configure terminal. We're going to make an access list. These access lists can get really complicated, but we're going to keep this one simple. Okay, and the way access lists are processed, it's a top-down kind of a deal. So if we type in here, access list 10, deny host 192.168.1.12. Okay, now, in order to let all other traffic through, 10, permit anything. Okay, so only traffic that matches this statement is going to get blocked. Everything else is going to get let through. All right, good deal. Now we have to go to our configuration of our interface. Okay, and interface G00 faces the .1 network, and so we're going to enable this access group. IP in. Okay, so what that means is that any traffic from this network that's coming into this router is going to get inspected. All right, now that we've done that, let's go back to PC 11 and let's do our ping again. Ping 2.100. Okay, that works. Now let's see what happens here. We're going to try to ping 2.100 and it should get blocked. And sure enough, it does. Okay, now from the .12 PC, we also can't ping. We also can't ping the router interface either. Okay, but because PC1 and PC2 are connected to the switch, if we have traffic here that's just MAC traffic, so in other words, whenever we type in an IP address, it's going to send out an address resolution protocol message. And if the node is on the same network, then it'll get a MAC address back that can be associated with that IP address, and we should be able to communicate back and forth as long as we don't leave the network. And we can. Okay, so PC1 and PC2 can talk to one another. PC1 can talk to the server. PC2 is blocked from the server. Okay, so that's how this lab should have been. I apologize for, whenever I came in, I just worked that lab up in the morning, and I thought it was good to go, but it wasn't. So I came back and I was like, man, why didn't that work? And then I got to looking and I realized, oh, shoot, address resolution protocol is not going to go through that router, even though it's a designated gateway. Okay, so anyways, long story short, that's why that thing didn't work. But all you guys are going to get 100, and I will also give you the answers to those reflection questions next time we meet. All right, well, thanks very much, and I will talk to you guys again later. Oh, and by the way, I'm going to go ahead and upload this information into Canvas so you guys can play with it on your own time and, just see how it works. All right, have a good one.